Good morning. Yeah. So today we'll talk about the Python enhancement proposal 458. Actually, it's how to protect the PyPI repository. So, but we get there in a few minutes. We'll start first understanding what's the problem here. So, yeah, I'm Kairo. I'm from Brazil. I live in Netherlands. I'm based there. So let's get started. So the question is why we should protect content distribution in our supply chain. When we talk about content distribution, we talked about protecting artifacts or protecting repositories. And this is not something related to how I produce artifacts, but how I protect my users to get in those artifacts, right? What's the problem here? So let's think about PyPI or any other repository. What happens if one artifact, one package, Python package, get compromised, tempered in this repository? This is really serious because this is a really massive attack surface. We know that we have a lot of dependencies. Let's get one situation. What happens if request gets compromised? Most of you here have used the request once, so your software will be compromised as well. So this is a massive attack for compromising the supply chain. So if you get a repository compromised, you can really make a lot of damage out there. So we have a solution that is not new. We sign artifacts, right? Simple. You have a private key, so you sign a package with this private key, and you provide the public key to your user, so they can check and validate if the signature of the package or the signature of an artifact is really, it's what you expect as the package. It was signed by the authority that you trust. But yeah, sign package is not enough. I came from Netherlands, never do this there, so otherwise you not see your bike. So, because the problem is who I should trust or no longer trust, because what happens? The ideal thing is to have multiple keys and sign the artifact, have a way to verify if the authority is still valid, if the signer is still valid. So it's more or less what you should do in Netherlands as well. Use multiple locks there. It will guarantee your bike will be there. So let's understand the problem from the perspective of the real situation. Let's say that I'm not talking about PyPI here only, but let's say your organization. So you have a private key, you have a public key. So what happens if someone from your organization that has access to this private key leaves your organization? So this is a problem that you need to solve. Basically, you need to generate a new key and resign everything. So if your key gets compromised, you see here a situation. The key for MSI was leaked and it damaged. This is another situation. The Samsung Android app sign key was also compromised. So what I'm telling here, it's not something new. So, of course, if you have this situation, you know what to do. You get a new key, resign everything, and distribute your new keys to your users. So, well, let's talk about PyPI or NPM. They have millions of packages. So imagine that you need to resign all million packets again. Or let's go beyond. You have CDNs and mirrors across the world. So you sign everything. You must guarantee that everything is signed, but you might have some mirror that it's offline and will be not able to sync. So the users that are reaching this mirror is still getting their old keys. So it will not match. And how you notify the users about the new key, right? And if you think, it could be also a way to attack. You could be a man in the middle here and say, oh, here's the new key, trust on me. This is a way to attack, right? Well, for solving this problem, we have this framework, the update framework. This is not new. It's more than 10 years old. is there. We call it TUF. So this is really interesting solution to protect repository. It doesn't matter if it's your organization, PyPI, or others. So how we use TUF? TUF sign everything. So actually, we don't sign all the artifacts. We sign one single metadata, but this single metadata has different roles that can help to protect the integrity, the freshness, and consistency. It means that the user can know that if your repository is fresh, if you rotate a key and your mirror is using this key, if this key is new or not, if it's fresh, and how consistent you are structuring the repository. So you can manage really trust in a scale, and it reduces the impact of compromise. I mean, if you have one key that was compromised, leaked, or someone rotated, you can go generate a new key without impact to your users. And it allows in-band recovery. It means that if one key is compromised in a certain moment, you can rotate this key, get a new key, and it will not impact the user. So the user you don't need to go to the user and say, here's my new key, trust me, is me saying that this is the new key, you should use that. Because this is the big problem. Most of you have CI, CD in your environment. I believe, like me, most of you don't check the signatures of the packages you download, right? But if you do this, you need to update all your CI/CD pipelines, saying, this is my new key, we need to use this. So the way that TUF does it, it's creating metadata roles with different relationship between them, and they can trust each other and set up a requirement and determine how you should go to trust one key. This is very complex. That's why I want to demonstrate to you that this is very complex. Because TUF is really tough. That's the reason that it's there 10 years and nobody used that. This is my son, first time that he tried ice cream, right? It was my feeling with TUF as well. So, but why this is so complex? First, the TUF specification, it's designed for the client side, not this repository side. So, and most of the implementations of TUF is done by big companies like Google use this, Facebook use this, but they have a lot of engineers. Maybe you are in a small company and don't have this effort. Because implementing TUF really adds a lot of code to maintain in your baseline. And the process of TUF, you saw I was saying, oh, you can revoke a key, you can sign it. This is really complex. So manage this TUF process can really lead you to the inconsistency, and actually you have a metadata that doesn't work for your customers. But when you learn about TUF, TUF is awesome. Now my kid really loves ice cream. And this is his personal record. Was 4 ice creams in one day. We were in the resort. And it was funny because he asked a new ice cream. I said no. And he asked me another beer. Yeah, so let's have it. Okay, but I'm here to talk about PEP 458. What's the Python enhancement proposal for 458? In the simple words, PyPI, we use TUF to protect ourselves. So we need to implement TUF to PyPI. Well, some background here. So this PEP was created in 2013, 10 years. Well, and not in production yet. So yeah, you can show it for your project managers, how something can be delayed. Yeah. Well, what's the problem of PEP 458? If you go to print it, it will be about 40 pages. And I was the second person to try to implement it to the PyPI. And my second try was 3,500 lines of code to be maintained by PyPI maintainers later. And nobody was reviewing that because it's crazy. You need to have the expertise about TUF to maintain this line. So what's the solution for this problem? Well, let's hide the complexity. Let's hide all this complexity that I told you about TUF, right? So we did it. how we did it? We didn't implement TUF in PyPI. So we hide it, they don't have TUF, and solve it, right? Yeah, but we need to implement it. And we create the repository steps for TUF. It's a project that was originated at VMware, but in the very beginning, we donated to OpenSSF. That's part of the Linux Foundation. And now we are implementing, really starting the process to implement the PEP 458 to PyPI. But what's the benefit of RSTUF instead of implementing TUF direct to PyPI? Well, most of the repositories, they are alike. Let's say that your organization uses JFrog Artifactory, or you see you just provide to your users to download your software using an HTTP server. Doesn't matter, because most of the repositories, they are alike. Then they are different. You said it, and was really something to help us. And we are really abstracting the TUF specification complexity, but I'm not doing it myself. I'm not capable to do this. We have a lot of people involved directly to TUF doing this with us. So this is a really cool project. So what's the design of our stuff? The idea is to be easy to deploy. I mean, anyone here can use this in your own organization or other open source projects. We want to scale and keep the consistency of the metadata to the users and to be easy to integrate. So REST API. So everybody can do it very easily. So this is a simple example from the big picture how our stuff fits to PyPI or even your organization. So most of you are familiar with this. You have code, CI/CD, building the code, and then you ship your software to your repository. So let's say JFrog Artifactory or your HTTPS server that exposes this. Well, you just need to add one inside of your build system. You deploy our stuff, and you do calls to this API. Doing your process, then you have the metadata together with your repository, so the users can use that. So this is a simple example using GitHub Actions. You see that it's not to go through the code in specific, but I want to show that I do basically API call and give the information of my package. The size, the hash of this package, let's say Shay256 or Blake2B. Well, and I told also that the process about managing TUF is really complex. I mean, how I create my first metadata, how I sign my first metadata. What if when we need to sign the metadata, I mean, the key holders need to sign it, what's the process, how we do this. So we have a CLI to help the users to do this, and this is really guided. So first we give examples how you should structure your organization. And also, we ask step-by-step questions. So you want to add a new key, you want to remove a new key. And with this colorful CLI, just to make visible what you're doing. And why our stuff is good not on PyPI, but to your organization or other products, and I will prove it here. So first, it's artifact agnostic. We don't care if your organization, in the end, is releasing like a software or a media, like documents to your customers. We want to protect when your customers need to fetch your artifact, doesn't matter what is this, to their machine, and don't get something compromised from, let's say, a bad repository. This is completely language agnostic. Of course, we are talking here about Python, so you just use Python to do the integration. This is really release process agnostic, like I demonstrated. We don't care how you build your artifact. If it's just a document, a Google document, you can just protect it. It's not a problem. Or it's a complex software with building tests, everything. It's not a problem. And you can deploy our stuff on your private or public cloud or on premises. And the repository is agnostic as well. I said you can store your artifacts wherever you do it now. HTTPS servers, S3, FTP, JFrog artifactors, keep as is. So what's the features we have in RSTUF now? We can do the bootstrap ceremony very guided, so you know how it works, importing the existing artifacts, because we want to protect not from today, but what you already released in the past you trust. You want to protect it, add and remove artifacts, be able to rotate the keys. Let's say your key is compromised. Oh, let's have a new key. Or you can have distributed asynchronous sign. This is a kind of, let's say, PyPI maintainers are across the world, US, Europe, Asia, and they need to sign things. They don't need to be together to sign it in the same room. They can do it remotely. Now let's show how it protects in the end the end user and how it doesn't change how things work. So this is my environment, development environment. This is PyPI. Most of you are familiar with this, but this is, of course, my development environment. You see my project here, and I have my latest release. So I'm a developer, so I will push a new artifact there, a new Python package. This is Twine. Most of you are familiar with this. It's a way to upload a package to PyPI. So I'm doing the upload here using this. You could be using CI/CD. You don't see chains. Besides, PyPI here in my machine is using RSTUF. So you see the new release there. It's available, and nothing changed. So let's see now the other side, the client. You are familiar with PEP. PEP install something. So here I'm installing with PEP. So you see that it would not, when PyPI has PEP 458, you will not change your usability. It's the same. You don't need to manage TUF or something like that. So, but if you see the details now, you can see that it's checking some constraints in the metadata, signatures, everything. I will not show very deep, but I will show here that this is looking for some metadata. I told that we have different roles. So timestamp, snapshot, tags are different roles here. They check the freshness, the consistency, and you might be curious, how looks this metadata that I'm talking often here? So this is the metadata. It's not one-to-one. One metadata stores many files. On top, you see the signatures. So this is how the metadata will look, but it is transparent for the user. The user don't need to manipulate this. It's embedded in the PyPI and the PEP. So here you see I'm simulating an attack on PyPI. Let's say that I get access to the PyPI server, and I'm tampering one of my package. So I'm adding like a malicious content on this file. So what we expect from the users are the user be protected when they try to download it. And we'll see when I try now to do the pip install of this package, it's raising an exception here. Of course, we don't want the user to see the exception, but it's just to demonstrate that it went to the metadata, and the metadata, the client say, oh, there's something wrong here. And it comes from TUF, all this infrastructure that manage the signatures and trustness. So that's how I want to demonstrate PyPI. In the future, we want to everybody using this, but you not feel it. That will be the nice thing. And also, if you have, here's another example. If you have users that do live updates from your software, you can implement it, and it will be transparent for them, and they will be protected about attacks on your repository. If someone gets in your repository, it will be protected. So, and to show that this is not only for PyPI, we have an interesting thing here. RubyGems is starting to use RSTUF as well to protect the Ruby users. So here it's a demonstration from the same what I did with PyPI. So push the gem artifact, then it's changed, and you see that it's failing to the user to download it because this is a protection to the user. Well, to see, I told before that the first try to attempt, my attempt to add PyPI with TUF was 3,000 lines of code, and this implementation for RubyGems, that is a huge repository, was it fits in one single screen, all the implementation to use to protect their users. So, and here's the Yosef. Yosef is one of maintainers of RubyGems. And he said, oh, yeah, it fits in one screen. And this is the Justin Kapors, the professor that created TUF. He was also impressive because usually this is a lot of code. Well, just very quick overview about the client side. How I implement the client side, because you saw that people was protected by RSTUF when you try to download. This is really simple. If you see, this is an example of a Python TUF. It's easy to implement like request. If you see here, this is the full implementation to download artifacts. So if you call this function with the artifact name, it will reach the repository and will be protected. So it's very simple. And you have different libraries, not only for Python. This is for Go, TUF, Rust, many other languages. And how this client works, how your user will be protected. Let's say that you have a software that you have, like, the user hits the button, like, update now. So this is what happened. It goes to the server, to the repository, gets the metadata, the TUF client on your side do the validation, and then it downloads the artifact. So, and you add a small bunch of code, but you also remove all the code that downloads things for you, because it's embedded in the client side. So what are our future plans? We are supporting to store the metadata in different storage services, like AWS S3 is already supported, Azure, and also the key, because some keys, online keys to sign it dynamically, needs to be in a different vault, so we are supporting KMS, Azure, and others. The custom delegation, it means that you can create teams to take care of parts of your repository. If you have multiple projects, you don't need to have multiple setups of our stuff. You can have one single and distribute the responsibility of this project. And also, we want to consolidate emerging technologies, like you may heard about these here or there, SigStore, Salsa, in total. So these all are working together with us. And that's it. RSTUF beta it's out. PyPI is working to have it. RubyGems, you saw, also is working to have it. We have also Conda, it's interested to use this. So, but also I know organizations that are doing this to protect the application, different level of application. That's all I have for you today.
So my VP engineering is very security conscious, and we've started using pre-commit, which is a tool that lets you define all of the CI/CD steps and linting and stuff. But pre-commit doesn't have its own repo. It works by you just include arbitrary GitHub repos into it, and with like a tag for the version. But there's not really any security there. Is there anything that a tool like pre-commit, or that we as clients, is there any way that we can get some benefit security-wise from a tool like RSTUF?
It looks more, if I understood correct, I'm not familiar with the tool, sorry, but it looks more familiar to attestations, like you can define the repositories you trust or not, right? You could, and you store this in some metadata or configurations or not?
It's just a very, like you want to run black, or you want to run a bunch of filters, in your project before you do the commit step. So all of those dependencies that you put in, it's just a GitHub, URL and release tag, and that's it. There's not like hashes or any.
Okay.
So if there's something as a client that we can do to protect ourselves better.
I could understand more with you, more details, but basically you could at least protect those files to be not changed and by others. So Imagine that I can do an attack on this situation. I can go to this file that you have and modify this file, pointing you to a malicious direct repository. So TUF could protect you in that side as well. But if you want to discuss more, I'm free.
Cool. Thank you so much.
Thank you.